The second part of our learning target says, I will be able to graph linear equation word problems in standard form. So we're revisiting one of the scenarios that we looked at last week in which we wrote an equation in standard form. So let's review. At the local gas station, donuts cost 50 cents each, and each bag of chips is $2. You have exactly $15 to spend and plan to spend it all on junk food. Write an equation in standard form to model this situation. So X is going to stand for the number of donuts, Y stands for the number of donuts. X stands for the number of bags of chips. Each donut is 50 cents. Each bag of chips is $2, and you're spending a total of 15. So just to review, standard form is when it's written in the form AX plus BY equals C. So here's our equation. 0.5y or 1/2 y plus 2x equals 15. So now we're going to graph this scenario. So I've put the equation again at the top of the page, and I've also included those steps that we take to graph a linear equation word problem, the same ones that we used when we graphed the equation in slope-intercept form. So the very first step is to give your graph a title. And I realize now, when I'm looking at it, that I forgot to do that ahead of time. So let's pick out a title. It can be very generic. I'm just going to write donuts and chips. Just going to keep it very simple. The second step is to label each axis, your x-axis and your y-axis, with both a title and numbers. I've already given them a title, and now we need to determine the numbers. So since we previously decided that X was going to stand for the bags of chips, I made sure that that label went with the x-axis. And then since we earlier decided that Y would stand for the number of donuts, I made sure that that went with the y-axis. So now we have to figure out how to label with numbers and what our scale is going to be. And sometimes I think that's the trickiest part, which is why I always recommend using a pencil. Because if you pick a scale that's just not going to work and you find that out later, you can easily erase it and go back. So let's start with the chips, which is X. And since chips are a little bit more expensive and I only have $15 to spend, I'm not going to worry about trying to fit as many numbers on the x-axis. So I'm going to count every other mark as, or every two, I should say, as one bag of chips. So I'm counting every two little marks here, and I'm labeling as I go. Oops, that should be a 6. Chips are a little bit more expensive because they're $2 each. Now I have to figure out how many donuts I can buy. Now donuts are very cheap. They're only 50 cents. So that makes me think I'm going to be able to buy a lot more donuts. So I need to fit a lot more numbers on my y-axis. So I'm thinking what I need to do is go by twos. So every mark is actually going to represent 2 donuts. So that's 4, 6, 8, 10. I'm only going to label every few here, but I'm going to go by twos. So that's 14, 16, 18, 20. Hopefully yours is going to be a little bit neater because you're going to be doing it by hand. 22, 24, 26, 28, 30. All right, I'm going to stop there. All right, after you've labeled each axis with the title and the numbers, now I recommend creating a table of values with 2 to 3 or more points. Now, since this equation is already in standard form, last week you learned both through the assignment and video instructions in the module and then also in your VC, you learned how to graph equations in standard form. And the quickest and easiest way to do that is to find both the x and y intercept. So you can see that I've already put zeros in the table of values that I created here. So let's start by finding the y intercept. And the way that I'm going to find that y-intercept is I'm going to plug a 0 into my equation for x. Remember, when you multiply anything by 0, you get 0. So 2 times 0 is 0. And then I'm left with 1/2 y equals 15. So to isolate the y, I'm going to divide both sides by 1/2, or 0.5. 15 divided by 1/2 is 30. So if I buy 0 bags of chips, I can buy 30 donuts. Now I'm going to calculate my x-intercept, and I'm going to do that by plugging a 0 into my equation for y. So now I'm going to do 0.5 times 0, which is 0, plus 2x, so that canceled out, by the way. So then I get 2x equals 15, divide by 2, divide by 2, x is equal to 7.5. So I always feel a little bit better when I'm graphing an equation if I have one other point. So I'm just going to pick a number and I'm going to plug it into my equation to find one other point here. So I'm just going to say, what if I buy 6 bags of chips? If I buy 6 bags of chips, that means I'm going to plug a 6 into my equation. 6 times 2 is 12. So then I get 0.5y plus 12 equals 15. I'm going to subtract 12 from both sides. And since I don't have a lot of space here, I'm going to jump to the next step. So subtract 12, and then I get 0.5y equals 3. And then I'm going to divide both sides by 0.5. 0.5 divided by 0.5 is 1. And 3 divided by 1/2 is 6. So now I have 3 points to graph. I've got my y-intercept, which is 30. So that's 22, 24, 26, 20. So that's a point right here. That just means if I buy 0 bags of chips, I can buy 30 donuts. If I buy 7.5 bags of chips, which is right here, I can buy 0 donuts. And if I buy 6 bags of chips, that's here, I can buy 6 donuts, and that would go right here. And you're doing this by hand, so you definitely want to make sure that you use a straight edge. This particular scenario does not, I'm doing terrible here. Use your straight edge, so yours looks much better than mine. But this particular one will not go into the negative value, so you don't have to include the arrows. So just make sure you know what scenario you are graphing and if it makes sense to include the arrows or not. And then last but not least, last week we answered some questions using the equation, but now I want to show you that you can also use the graph, although my graph may not be super accurate because I didn't use a straight edge. But this one just says, if you plan to buy exactly 4 bags of chips, how many donuts can you buy? So using your graph, you're going to go down to chips and you're going to find where it says 4, which is right here. And then you're going to go all the way up until you hit the line. And then you're going to look to see where it hits on the y-axis. And I don't trust my graph, so I'm not going to, I can get an approximate answer. But since I didn't use a straight edge, I feel like I need to use the equation as well. So let me just check it with the equation. So chips was x. It was 2 times 4, which is 8. So that means 0.5y plus 8 equals 15. I'm going to subtract the 8. I get 0.5y equals 7. Divide both sides by 1/2. 7 divided by 1/2 is 14. So let me just go back to the graph one more time to see it. 4 bags of chips. Yeah, actually it is super close to 14, but again, my graph is just not that great because I didn't use a straight edge. So now you can see the importance of using a straight edge. And then the second question, If you buy exactly 6 donuts, how many bags of chips can you buy? So again, I'm not going to solve it with the graph because I didn't use the straight edge, but I'll at least show you. So you would go back to the graph and you would look at this time you're going to look at the y-axis and you're going to focus on 6 right here. You can see where I'm trying to draw. And then you would go over. Well, in this one, we already got the answer to, and I put a point there. But you can see that you look down to see where does it touch at the x-axis. And it would be 6 donuts would be 6 bags of chips as well. So I hope this helped you to feel more confident in graphing in standard form, specifically a word problem.